Hello and welcome. My name is Scott Nielsen. I'm the Product Director for COBOL here at Micro Focus. Today we're going to look at modernizing COBOL applications using the Microsoft Azure Cloud. First of all, we'll use the Azure Serverless computing platform to create a REST API to access COBOL business logic. Afterwards, we'll use the Azure DevOps stack to create continuous integration pipelines that will build, test and deploy our application following any code changes. Here's a quick summary of the steps. We'll start with an existing COBOL application, an application used by a fictitious opticians company called Microfocals. Next, we'll use code analysis tooling to slice out a piece of self-contained business logic from the COBOL code that we can use as an API. We'll see how Visual Studio can provide a contemporary development experience for COBOL developers, and we'll even write some unit tests against the COBOL code. Once this is complete, we'll set about building an API using a mix of C# and COBOL. And finally, we'll look at how we can create CI and CD pipelines using Azure DevOps. Okay, let's get started then. Here's the COBOL application we're going to be working with. And like many COBOL systems, it has a character interface that you navigate using a series of menu options and keystrokes. Here I've homed in on a piece of the application used to set up and configure a specific store. I can see details about the store, such as contact information, and there's even a geolocation too. This looks like it could be a good candidate to create an API that exposes this functionality in some way. Okay, so here's the code for the Microfocals application loaded inside of Visual Studio 2019. The application is split across two projects, a main executable and a library. And I can see all the code used to create this application, and I can even see which copybooks are used by a given program. While we're here, let's take a look at a few features Visual Studio has to offer COBOL developers. First of all, I can expand copybooks inline. I don't need to open a separate editor. Now let's jump to the procedure division using the quick navigation tools. If you make a mistake, a typo, you'll soon get to know about it with some red squigglies. While I'm here, I can also do some refactoring. I can rename this identifier and see the changes across all of the source files. But I think for now I'm going to leave this one just as it was. New in our 5.0 release is peak definition, which allows you to see the definition of an item at the cursor. Here I can see the section of code I'm about to perform. And here's something a little quirky to finish on. You can even turn the scroll bar into a map mode to quickly navigate around the code. There's plenty of developer aids on offer inside of Visual Studio 2019. But for now, let's leave it there and turn our attention to the application architecture. We're going to use code analysis tooling to help us understand how the application is constructed. The Microfocals code base has already been loaded into the repository, and we can now start to query and search the code for points of interest very quickly. First, let's start with an inventory report. And it looks like we're dealing with about 10,000 lines of code in this application, which is spread across approximately 90 files. So let's explore the repository a little further and learn more about the code. It was the store details that we were interested in exposing as an API. So let's see if we can find that code. Let's search for store, and we can see we get a couple of hits. Let's drill into the store maintenance program. There's the code on the right hand side. We'll drill further into that application. We can see the screens that it's using, and COBOL Analyzer can show us what those screens would look like at runtime. And this certainly looks like the right part of the code we were looking at earlier. Up above, we can actually take a look at the data that's being used by this application as well. There are two data files being used here, a store file and a store configuration file. And looking closely at the store file itself, we can see a range of operations are being performed on it, and the file in question is called stores.dat. Armed with this information, let's look at a data flow map so we can see how this file is being used in the rest of the application. The data flow map shows all the files being used across the code and the different types of I/O each program is performing against the files. We can see some programs are using more than one file. Here's the store file we found earlier, and it's being accessed by multiple programs. Store popup, get def store, and store maintenance are using both stores and store conf files and are performing different types of I/O. We can also see there is one program called get1store that is just reading the file. And this program is probably a good candidate to explore for our API. So let's see how get1store fits into the overall application by creating a call map. Now, like most legacy applications, there are many moving parts and lots of calls between different programs. But we can filter out the noise to get a much cleaner view of the application architecture. That's looking a lot better. We can try some different layout options to find one we like. I think this one looks good, and we can clearly see the main menu program and the sub-programs that it calls. And if we look to the right, we can see our get1store program is relatively isolated. So let's extract this into its own separate project. So if we select the get1store program, we can include this code and all the related programs it needs into its own project. Here we can see the new get1store project and the files it needs to run. We're now just a step away from extracting this as a project that we can use inside Visual Studio. So then, back in Visual Studio 2019, we've got a new project that contains just the code we've extracted using Analyzer. This code will provide the main business logic for the API. Now, if we take a look at the main entry point for the program, we can see it takes a single input parameter, which is the name of the store you want information for, and it returns the details of that store, such as the contact information and geolocation, in a group item. Now, while we're here, we can also take a look at the index data file that's being used by this API. We've also got that packaged inside of the project, and we can see records for each of the individual stores, contact information, geolocation, email address, and so forth. Okay, now before we build an API around that code, let's write some unit tests to validate it's actually working. We'll use these same unit tests later on in our CI system. I can use Visual Studio to generate a test harness for us, which will appear in a separate project that we can use to call the main program from. From here, we can easily code up a test. Let's write one to ensure a store has at least one consultant assigned to it. As long as there's at least one consultant, this test case will pass. But if there aren't any consultants, we'll issue an assert to indicate there's been a problem with the code. Okay, we're just about ready to run those tests. First of all, the test case will get compiled, and after a few seconds, we should see it execute, and the results will be in the unit testing window for us to examine. And it looks like everything is green, so the tests have passed. But let's indicate a test failure. Let's change that if statement rerun the tests, and we can see these tests have now failed. Now I've imported a much more comprehensive set of tests that we've already written. These test date validation logic within the main application. Let's run them as we did before. They'll get compiled and we'll see the results. And most of the tests look like they're passing successfully, but there is one that seems to have a problem. We'll come back and look at this later on. Now just before we go any further, let's rerun those tests, but this time with code coverage enabled. After a few seconds, once the tests have run, the code coverage window will report the amount of code that's actually been executed by a test. We can see we've got about 70% coverage, and if we open the program that was being tested, lines of code tested are in blue, but anything that was missed will be highlighted in red. And we do seem to have a problem in this area. Again, we'll take a look at this later on. Okay, it's time to create our API. This is a C# Azure function project. The main entry point receives an HTTP request, and within that we look for a parameter called name. Next we set up the call to the COBOL program, and we're using classes that were automatically generated by the COBOL compiler. You should recognize some of the fields here as those being from the COBOL program itself. Next step is to actually call the COBOL program, and we use an API to isolate this call from any others to the same program occurring within the same process. And once we got some results back, we format those as a JSON response. So let's set a breakpoint in this function. Hit F5 to run the application, and at this point the Azure Compute emulator should start up. And after a few seconds we'll be presented with a URL we can use to invoke our API endpoint. Let me copy that and paste it into a browser. I'll specify the parameter name to be equal to London, and now we should hit our breakpoint in C#. Let's step through the code here, check on the parameter that's being passed through, continue stepping through the code, preparing the call to the COBOL application, and here we should step straight from C# into COBOL. This is the existing COBOL program that we extracted using the Analyzer tool. It does the job it always has before returning the results back to the C# application. And if we let this complete and go back to the browser, we should see the JSON formatted by the browser. Okay, so our API appears to be working correctly. We can now publish it into Azure. I can do that directly from Visual Studio here, and after a few moments it'll be available to be called. So let's switch to the Azure portal. Here's the function deployed and our get store info API. We can even test the API here in the portal. We click test, we can see the results in the right hand window. So with the function now accessible, let's finish this section by connecting a modern user experience to the API. Before we do that, let me just grab the URL where the API is hosted. Okay, so back in Visual Studio, I've got a website project ready to call this API. Let me paste the endpoint URL that's going to be used in this parameter. We scroll to the bottom of the code. This is where we're actually calling the endpoint itself. Let's run the website. We should see a browser pop up momentarily. And from here, we have a more modern, contemporary user experience. We can type in the location of the store that we're interested in, and after a moment we should see some results with contact details about the store as well as a map showing us its location. So there we have it. We've extracted COBOL business logic and deployed it as a serverless application into Azure. But we can take this one step further and set up a continuous integration and continuous delivery pipeline for any time we change the code. This is Azure DevOps. From here we have access to a source code repository, and we can set up automated pipelines to build, test and deploy our function. Let's take a look at the code repository first of all. Here's all of our COBOL and C# source code and the Visual Studio projects that we've been working on today. All of these were committed directly from within the Visual Studio IDE. Now let's take a look at the pipelines. What we're looking at here are the results of some previous builds, but let's look at the steps that are executed whenever a code change is made to the repo. You can see steps in here to build the application, a step to run the unit tests, and steps to publish the results from this pipeline. Now let's take a look at the releases pipeline. This pipeline gets triggered whenever there's been a successful build. Tasks here publish the results of our build into Azure to update the function. Let's try it out. Okay, so we're back in Visual Studio, and if you remember, one of our test cases was failing previously. Let's get that fixed. When we looked at the code coverage results, we could see that an area of code was not being tested. Let's run some analysis features that are integrated into Visual Studio to help locate the cause of this. We can perform a range of different scans, but for now I'm just going to search for any dead code in this program. Code that can't be executed. The search reveals dead code in the same spot identified by our code coverage test, so something's amiss here. If we look at this code indentation, it gives us some clues as to what the developer might have originally intended. But the real culprit is the validation section below. All code paths will exit the program, making any subsequent code unreachable. To fix this, let's make this a nested if to match the code above. And while we're doing it, let's auto-format the code to get the indentation matching the if statements. That looks better. If we rerun the analysis, we shouldn't find any further dead statements. And now let's build our code. And rerun the failing test to make sure it's passing. That's looking better. Let me make one further code change before we commit everything back to the repo. So far, it's the C# code that's been calling into COBOL, but there's no reason COBOL developers cannot call C# and the .NET framework too. Here we are back at the code that's being called by the C# function. I'm going to call a .NET method to retrieve the local time using the geolocation we have stored in the data file. This shows how COBOL can also access .NET Framework functions and other languages in the .NET Framework. But if we take a closer look at the code we're invoking, it's actually a COBOL class which is calling a Google Mapping API using a REST service to get the local time. This integration allows COBOL developers to not only take existing procedural code into .NET, but to extend it using all the .NET Framework has to offer. So we've built and tested our code. Let's commit the code changes and trigger the CI pipelines. If I switch to the Team Explorer, it's connected to our Azure DevOps repository. Here are the files that I've changed and a commit log. Let's commit these files to the Azure repo. So let's switch back to Azure DevOps. And after a few moments, once a change to the repository has been detected, a new pipeline build will commence. And we can see it's starting to build our application now. While that's progressing, let's just go and take a look at the repository. Here's the commit that we just made at the top of the list here. And if I click this, you can see the diff of the code, the lines I've added and the lines I've removed. Let's head back to the pipelines. Let's look at one of the previous builds that we've done, and we can check on the tests for that particular build. You can see we had a failing test here, the one that we hope we fixed. We go back to our build, check on its progress. We can see the different phases underway. It looks like it's almost finished here, but we can still check the status of the logs. Here's the output from the build itself. And if we now go to the releases pipeline, we can see the deployment is in progress now. So the function is being updated with the new code we've committed. That's going to take a few seconds to complete. It's now done. All right, let's try it out. We can refresh the browser and we should see the local time enhancement appear. Here it is for Salt Lake. There's the map and the contact details, and here's our local time enhancement. It looks like we've still got enough time to call and make an eye test appointment. Now, before we wrap things up, let's look at one of the benefits of using the serverless platform architecture. Here's one last piece of code to look at. It's a COBOL application designed to repeatedly invoke the API to get details of stores in towns and cities in the UK. It's off and running, and if we switch back to the Azure portal, we can now see a live stream of the incoming requests and their duration. In fact, we can already see that Azure has automatically deployed this application across 2 servers to meet the new increased workload and is load balancing the requests across the machines. As you can see, there's plenty this platform has to offer. But for now, let's summarize what we've done. Well, I think we've covered a lot of ground in a short space of time today. From API development using Azure Serverless computing, to unit testing and DevOps pipelines, from mixed language development in Visual Studio 2019, to application understanding and business logic extraction. If you're wondering about your next steps with COBOL applications, I hope this has been food for thought. If you want to find out more about any of the products you've seen today, or if you want to try this out for yourself, you'll find all you need to know here. Thanks for watching.